Hello and welcome my dear students. Today's masterclass is on geometrical optics. And again, for all the students who are new to Vedantu Masterclasses, let me tell you Vedantu Masterclasses is a classic fusion of the best of teachers with the best of technology. For all the students who don't know me, my name is Namo Kaul. I have been a physics teacher and mentor to tens of thousands of aspirants for close to a decade now. I'm also the proud inventor of Turbo Math, which today is one of the most successful courses in India. Let me also tell you that I have been certified by the Indian Association of Physics Teachers. Apart from that, I have also been awarded recently at the National Teachers Conclave in 2018, which was held in Bangalore, for best teaching and pedagogy. Okay, what are these? These are just credentials, my dear students, but these credentials are not the ones which bring me here. To be very honest with you, to be extremely plain with you, the only thing that brings me here is the love for the subject and my love towards all of you. And again, I love you all for all the support that you've given me so far. Apart from that, my dear students, let me tell you, it's an important thing for all the early students out here. We have two amazing surprise gifts for you, which we'll be disclosing at the end of this 1 hour masterclass. So again, the first surprise is something which will help you crack JEE. And when I say that, please make a note of this. The second surprise is something which I give to all my students. It is something which is beyond imagination. Again, which is like I say, it is very difficult for you to even begin to imagine how much it will be helpful in your journey in cracking examinations like JEE, NEET, AIMS and whatnot. So guys, let's get started with today's masterclass on geometrical optics. Let's get started right away. We will start with a very intriguing question, a question which will blow your minds away. I'll tell you why. Because knowing the question, as you look at the question, you will have an answer in your mind. And you know what? 90% of the students are wrong here. Okay, so the question, my dear students, is on your screens now. So this is the question. An incident ray of light is parallel to the principal axis. Okay, everyone see, it is parallel to the principal axis. So after reflection from a concave mirror, which is a spherical mirror, which point will it pass through? Okay, will it pass through C, F, P or somewhere between P or F? What is your correct answer? Everyone, give me your answer. A, B, C or D. Someone wants a hint? Try this question geometrically. Okay, side by side, I will also do this. Everyone, please see what I'm doing here. So I will approach this question geometrically, bachon. Please see this. I will approach this question geometrically. So I will join the point of incidence. Let me call this point of incidence as I. Okay? So this is the point of incidence. Now, if I construct CI will be the normal, right? CI will be the normal to the circle. Why normal to the circle? Because if you drop a normal to a circle, it will always pass through the center. So this is the normal at this point. Okay? So basically this angle is given to us, my dear students. This is the angle which is given to us as 60 degrees. So this angle is the angle of incidence. Let me call this I. I is equals to 60. Similarly, simple geometry, this angle will also be 60. Let's hold it right here. Apart from that, I will tell you students that majority of you think that it is focus. Many of you think that it is focus. Let me tell you students that it's a little heartbreaking, but this is not the correct answer. This is not the correct answer. So again, we have heard this so many times that any ray in ray diagrams, right? Any ray which is parallel to the principal axis will pass through the focus. Trust me, there is a terms and conditions applied to that. So this statement is wrong, that any ray parallel to the principal axis will pass through the focus is a completely incorrect statement. Okay, we will discuss what is the real statement after this. Okay, so this will really make our concepts really strong. So again, everyone, so what I'm going to do next is really mind-blowing. Everyone see this. So what is this length? So it's simple geometry. What is this length? Everyone see this. What is this length? ये length क्या है? ये R होगा. So ये length क्या होगा? Radius. So this is the radius of curvature. So CI is the radius, so it is R. Similarly, this is also R. CP is also the radius of curvature. This is also R. Okay. Now everyone watch this very, very carefully. I'm going to draw the reflected ray. So everyone please see. From here, if I draw the reflected ray, ठीक है? So ये तो clearly दिख रहा है. From geometry, it doesn't even look pretty symmetric, right? This angle doesn't look like 60 degrees. So basically it will pass through somewhere here. Now everyone watch this triangle. I'm talking about the triangle with the normal, with the green line and the principal axis and this red line. How can I adjust it in a way that all the angles of this triangle will be 60 degrees. All the angles of this triangle will be 60 degrees. When will all the angles be 60 degrees? I'll tell you why I'm saying what I'm saying. The only reason why I'm saying it is because I know for a fact that following the laws of reflection, okay, laws of reflection, this angle also has to be 60 degrees. This angle also has to be 60 degrees, angle of reflection. So if I adjust it, bachcho, please have a look at this. Beautiful problem. If I adjust this line, it will become 60 degrees only when it passes through the pole. Why? Everyone see this. Why 60? Why all the angles have to be 60? Because this is 60 and this is 60 because of the angle of reflection being equal to the angle of incidence. So ye 60 hai, ye 60 hai. If this is 60, this also has to be 60. And it will only be 60 if this is equals to radius, this is equals to radius, and this will also be equal to radius. It's amazing, beautiful geometry out here. And just have a look at the beauty of this problem. The incident ray, which is incident at 60 degrees on the mirror, and it is parallel to the principal axis, doesn't pass through the focus. It passes quite away from the focus. It passes through the pole. So the correct answer, my dear students, is pole. I hope you all could understand this. Now comes, what did we learn before this? Before this, in any ray diagram, we used to say that if this is pole, this is focus, and this is center of curvature. We used to say one very important thing. Okay, some of the students know this out here, right? That if a ray is parallel, will pass through the focus. Now let me tell you, that is only true for, this is the word, paraxial rays. Paraxial rays hoti kya hai? So all the ray diagrams that you've learned are only for paraxial rays, and trust me students, those rays are very, very close to the principal axis. So again, we cannot draw them on paper, otherwise you'll not understand. If I draw a paraxial ray, it will be like really very close. So you will not be able to learn and study. So that is why we draw the ray diagrams with some distance. But understand, if there is a paraxial ray, that is a ray which is parallel to the principal axis and very close to it. So if it is very close to the principal axis, then the angle of incidence is very small. It is tending towards 0. Okay. So always understand, all the ray diagrams that you've studied before this are for paraxial rays. So any paraxial ray which is parallel to the principal axis will pass through the focus. But any parallel ray may or may not. Clear everyone? Chalo, great. Amazing. This was really fun to solve, and I hope everyone learned something new today. So now let's move on to the next problem. Everyone, now let's have a look at this. So it's a concept here. So if there's a plane mirror, everyone please make a note. If there's a plane mirror, so if there's a plane mirror over here, ये plane mirror hai, and if you walk, everyone knows if you walk, your image will walk with you, right? So if I have a mirror beside me and if I walk parallel to the mirror surface, right? So I'm walking parallel to the mirror surface, so the image will also walk parallelly. Similar, what I mean to say here is that if I have a speed, let's talk about speed here. If I have a speed of 2 meters per second, then my image will also move like this at 2 meters per second. But does that happen when I walk perpendicular to the mirror? Absolutely not. Because when I walk perpendicularly to a mirror, my image also comes closer to me. My image also comes closer to me. So now everyone, now let's have a look at the perpendicular case. So here if I say that my velocity here is 2 meters per second towards the mirror, perpendicular to the mirror, then my image will also come at the same distance, 2 meters per second. So everyone can have a look at that. So everyone watch the camera. So if the camera is the mirror, so now just see, if that is the mirror, my fingers coming towards it. So the image will also come towards it like this. Okay? You all can try it out at home. You can go towards the mirror and you will see that the image also comes closer to you, right? So if this moves at 2 meters per second, this is 2 meters per second. So what can you make out of it vectorially? So I say that if the mirror is at rest, so here the mirror is at rest, plane mirror, if this is the velocity of the object and this is the velocity of the image, right? VO and VI. So what is the relationship that we can establish? The magnitude is same but direction is different. So I can just say that velocity of the image will be negative times velocity of the object. So this is very important. This is only for the perpendicular component of velocity. So a very important example. Let's also see this scenario in 2D. So for example, if this is the mirror, please watch this. So if this is the plane mirror, ठीक है, so ये mirror surface है तुम्हारा. So here, if I am moving at a speed of say 10 meters per second, if I am moving at 10 meters per second at an angle of 37 degrees, so I can break this into 10 cos 37, 10 sin 37. So 10 cos 37 will give me, cos 37 will be how much? It will be 4 by 5. So this will be 8 meters per second. And this component, I can break this velocity into two components. So this will be 6 and 8. 6 meters per second and 8 meters per second. So I have broken this velocity. जो resultant था, I have broken it down. So basically, it has a perpendicular velocity component of 8 meters per second and parallel component of 6 meters per second. Similarly, if I want to find, so in this case, I can clearly say velocity of object is 8 I cap plus 6 j cap. Okay, taking this as the y direction and this as the x direction. Similarly, if this is the object, my dear students, please watch this. If this green color thing is the object, let's draw the image of this. उतने ही distance पे mirror के अंदर the image will be there. I think everyone can visualize this really well. So this is the image. अब image अब देखो individually देखो parallel component is moving with 6. So image का भी parallel component will be moving at 6. Very intuitive, right? But when you are going closer to the mirror, even the image will come closer to the mirror. ठीक है? तो ये 8 हो जाएगा ऐसे. Clear? 8 meters per second. So what do you see here? This was the perpendicular component. This was the parallel component. So basically in image, how will you write the velocity of the image? You will write velocity of the image will be equal to, क्या लिखोगे यहाँ पे? 8 यहाँ पे, ये perpendicular वाला negative में हो जाता है. So this will be minus 8 I cap and this will remain, parallel wala will remain unchanged. So this will be 6j. Okay, so with this, let's test our knowledge with some concepts of reflection with relative velocity. Everyone, now let's have a look at this beautiful problem in front of you. Find the velocity of the image of the man with respect to ground. Understand this. This is very important. With respect to ground. You have to find the velocity of this man with respect to the ground. Now, this man is at rest. He is not moving. What is moving? The mirror is moving, right? So at this instant, the image is over here, but the mirror is moving. So what will be the velocity of the man? So obviously if the mirror is moving, the image will also move. By how much? So what is the best way of doing these problems? The best way of doing these problems, my dear students, is by bringing the mirror to rest, because all that we studied right now, in that the mirror was not moving. So first bring the mirror to rest and then solve the problem. इसको formally करना is always the best approach. So what is the velocity of the mirror? Please write this vectorially. Velocity of the mirror is 10 I cap. Taking this as the positive x direction. ठीक है? It is plus 10 I cap. That is the velocity of the mirror with respect to ground. Okay, what is velocity of the object or the man? Okay, I'll say velocity of the object. Object को VO बोल रहा हूं मैं. Velocity of the object is 0. So this is mirror, this is the object, and object is at rest. Velocity of the mirror is 10 I cap. So everyone, I will first find what is the velocity of the object with respect to the mirror, because I want to bring the mirror to rest. Okay? So I will say velocity of, please watch this, velocity of object or VO with respect to mirror. Matlab, I want to bring the mirror to rest. So I want to watch everything with respect to the mirror. Velocity of object with respect to the mirror will be VO minus VM, right? This is the basic formula. Velocity of O with respect to M is VO minus VM. Clear? So VO is 0. यहाँ पे देखो, VO is 0 and VM is 10 I cap. So what is the velocity of object with respect to the mirror? It is minus 10 I cap. ठीक है, minus 10 I cap. So what does this mean? That when mirror is at rest, now please get back to this. Now draw a picture of this to understand this. With respect to the mirror, what is the velocity of the object? So when mirror is at rest, okay, now in this case, what I mean to say is with respect to mirror, dekh rahe na? So mirror is at rest. So when mirror is at rest, object is moving, ठीक है, or the man is moving. So this man is having a velocity of minus 10. मतलब यहाँ पे इसकी 10 है. Okay, you've drawn a picture to visualize this. Okay, so this is all with respect to the mirror. लिख रहा हूं मैं यहाँ पे, दिस इज नॉट द रियल फिगर, दिस इज विथ रिस्पेक्ट टू द मिरर, है ना. एंड दिस वी यूज्ड द फॉर्मूला टू एंश्योर दैट वी डोंट मेक अ मिस्टेक विथ साइन कन्वेंशन. सो व्हाई एम आई सेइंग दिस? वी कैन डू दिस डायरेक्टली आल्सो, बट आई want to ensure that all of you use this until you get pro in this. ठीक है, otherwise you'll make a lot of silly mistakes, because I've seen students over the years make a lot of silly mistakes like this. तो ये 10 है ऐसे, तो image का क्या होगा? When the mirror is at rest, image will be moving with 10. So if this is the object, image will be moving like this with respect to mirror. ये सब कुछ with respect to mirror है. So this is the image. Image will be moving with 10. So what will you write? तो यहां से you understood very interestingly, watching this figure, you had this. So you can say velocity of image with respect to mirror is equals to 10 I cap by drawing this figure plus 10 I cap. ठीक है? So this is what you got. But this is with respect to the mirror. This is not with respect to ground or with respect to earth. So this is the velocity of the image with respect to the mirror, which is 10 I cap. ये ऐसे भी आ सकता है क्योंकि दिस इज द परपेंडिकुलर कंपोनेंट ऑफ वेलोसिटी, तो इसका उल्टा होगा. दिस इज व्हाट वी लर्न, राइट? सो दिस इज द वेलोसिटी ऑफ इमेज विद रिस्पेक्ट टू द मिरर. सो यू ब्रेक इट फर्दर, वी आई माइनस वी एम इज इक्वल्स टू 10 आई कैप. ठीक है? सो इफ यू ब्रेक इट, यू नो व्हाट वी एम इज एंड यू कैन फाइंड व्हाट वी आई इज, बिकॉज यू ऑलवेज वांटेड velocity of image with respect to ground, which is vi. So when I don't write anything, it means with respect to ground. So here vi will be equal to 10 I cap plus vm vector. Vm vector is another 10 I cap. So this will be 10 plus 10 I cap. So the correct answer will be 20 I cap. That means 20 meters per second rightwards. Okay. So the correct answer, my dear students, will be 20 meters per second right. C option. C is correct here. Now let's have a look at one more example and get started with this. Chalo. So here two things are moving. Now this makes it really interesting. Here the object or the man is the object and this is the mirror. Both are moving. So पहले सब कुछ प्यार से लिख दो. Okay. So object is moving. So velocity of object. What is velocity of object? 5 I cap plus 5 I cap. What is velocity of mirror? Velocity of mirror is plus 15 I cap. लिख दिया, very good. Now, it's very difficult to visualize when the mirror is moving. Bring the mirror to rest. How can you bring the mirror to rest? By writing all the velocities with respect to the mirror. ठीक है? So, I'm going to write what is the velocity of object with respect to mirror. So, this will be VO minus VM, velocity of object with respect to mirror. So, this will be VO minus VM, which is what? Minus 10 I cap. ठीक है? Minus 10 I cap. And whenever we visualize with respect to mirror, mirror is at rest. So now again draw that image. So this is with respect to the mirror, right? That means mirror is not moving. Mirror is watching everything. तो यहाँ पे this is with respect to mirror. ठीक है? I'm writing this with respect to mirror, where mirror is at rest. तो यहाँ पे object का velocity क्या आ रहा है? Please see, object's velocity is 10 here. Okay, so this is very similar to our previous question. So it is 10 here with respect to mirror. सब कुछ with respect to है. So ये 10 यहाँ पे जा रहा है. तो everyone visualize image का क्या होगा? If this is going away, image also with respect to mirror will be moving like this 10. तो यहाँ से just by the simple visualization we can write now velocity of image is 10 right? Velocity of image with respect to mirror is, when mirror is at rest, we can analyze everything. It is 10 I cap. Okay, it is 10 I cap. Now you have this. You wanted VI with respect to ground. You wanted VI, right? तो यहां से VI आ जाएगा. कैसे आएगा? VI minus VM is equals to 10 I cap. तो ये VM add हो जाएगा इसमें to get VI. So VI will be 10 plus V mirror. 10 I cap plus V mirror. V mirror is 15 I cap. So this will give you 25 I cap. So the correct answer, my dear students, in this question is 25 rightwards. So the correct answer is C option. I hope everyone enjoyed doing this problem. There is another way how to do this. ठीक है? I'll do this problem in a different way again. 25 right एक और तरीके से आ सकता है. So if someone wants to play around here, so I can tell you how you can do that as well. So always understand, in physics, this situation is equivalent to this situation. ठीक है? if two objects are at rest, or if both of them are moving with the same velocity, this is an equivalent situation in physics. How do you visualize it? Everyone please note. Now, if I ask you this question, please watch this. It's a very good visualization. If I am sitting here on earth, okay, this is me, and if you are sitting here on earth, okay, I am at rest, you are at rest. What do I say? We both are at rest at our positions, okay? So you will say I am at rest, I will say you are at rest. We are absolutely right. But what about if there is some alien or a spaceship, okay? So now this guy alien, Jadoo, है ना, इसने हमें देखा, and he says, what are you guys talking about? You both are moving. So again, always understand, in relativity, this is the most important concept, that this situation is equivalent to this situation. So when we both were talking with respect to each other, right, we were at rest, but if an alien watches, वो तो बोलेगा, okay, the earth is rotating also and it is revolving also. So there's a complex motion that both of you are doing. You guys are not at rest. Let me tell you, let me assure you that. So again, always remember that. ठीक है, तो अब let's do that problem with this funda. ठीक है, so this is the problem 5 and 15, right? Let's replicate this and I'll tell you how easy this can get. So this is the mirror. The mirror was moving with 15. ठीक है, ये बहुत fun है करना. So mirror is moving with 15 meters per second. And the man is moving with 5, ठीक है? So the man or the object, so this is the object, is moving with 5 meters per second, ठीक है? So now all of us know कि we can analyze much better if we analyze with the mirror at rest. तो अब don't do any partiality. अगर if this is 0, 0, you can impart a velocity of v to both of them. Similarly, वही चीज यहाँ पे करने वाला हूँ. I'm not going to do any partiality. I'm going to make the mirror come to rest. तो मैंने mirror को rest पे कैसे लाया? I gave the mirror an ulta velocity of 15, but I gave a 15 to this guy also. It's an equivalent situation in physics that I give a velocity of 15 to both of them. So what do I get? So now I'll say that from here I come to a state like this. Now this is the changed situation. Now the mirror is at rest. 15 cancel हो गया. So now the mirror has come to rest. That means I'm analyzing with respect to the mirror. Please see. Okay, mirror has come to rest. And this guy is moving with net कितना? 15 और 5. 15 और 5 कितना होगा? 10 here. ठीक है? Very good. Very visual. देखो 10. So this is exactly without writing any equations. पहले बहुत equations लिखे थे, but this is very good to visualize. Now this ball is moving with 10. So why is this important? Because generally in books, you don't find all of this. So everyone please make a note of this. देखो, this is a very good method. So now you've converted this situation to a situation with respect to the mirror because you brought the mirror to rest by giving 15 to both. तो ये हो गया. तो in this situation, image का क्या होगा? So this is the object and image. यहाँ पे image का analyze कर सकते हो तुम. So you will say image is moving with 10 I cap. Okay, so you will say that the image has a velocity of 10 I cap. But this is when this is watching with respect to the mirror because you brought the mirror to rest. तो तुमने respect दिया उसको. You brought it to rest. So this entire situation is with respect to mirror. ठीक है? So from here you have analyzed that the image velocity with respect to the mirror is 10. तो यहाँ से you got this. Velocity of image with respect to the mirror is 10 I cap. But what you were asked is velocity of image with respect to the ground. अब initial situation पे वापस आ जाओ. So now this is what you have derived here. Here you have come to know what is the velocity of the image with respect to the mirror. अब वापस से initially the mirror was moving. Now revert the changes. जो 15 थे वापस से सबको 15 दे दो. Give 15 to all of them. ठीक है? So this was the situation with respect to the mirror. Let's get back to the original situation. अब वो कैसे होगा? या तो ऐसे कर लो इसको. Otherwise revert back. Now revert the changes. But here we have got to know the image. तो अब यहाँ पे what I'm going to do is ये जो 15 लिया था मैंने इसमें, अब मैं सबको वापस से I'll give 15 and 15. So when I do that, image की velocity क्या आ रही है बच्चों? यहाँ पे देखो. Now I will get back the original situation यहाँ पे. But here I have the image also. It's a very visual and a very fun to do way. So this here the mirror is moving with 15. Object वापस से 5 पे आ गया. देखो, object has again come back to 5. But the good thing is here we have the image also. So this was the object. Here it is the image. Image यहाँ पे 10 था तो ये 15 ऐड हो गया तो ये कितना हो गया 25, right? So that is a beautiful way of doing this problem without involving any mathematics or formulas, and that is the fun way. So okay, this is always a visual way. Please make a note of this. If you've understood this, I think you will really enjoy this next problem where there's a car moving at an angle. Please see, there's a car moving at an angle. तो यहाँ पे image में भी ऐसे कुछ move कर रही होगी कार. Here we have to find out what is the velocity of the car with respect to the ground, the image of the car. Okay, image of the car जो इसमें बन रही है उसकी what is the velocity. But please watch out carefully. It is 5 meters per second at an angle, and here the mirror is also moving. So I would recommend you guys not to play around a lot with this question. इसको formally करते हैं. So everyone see, let's break the velocity. Velocity vector को you can easily break as v cos theta and v sin theta, right? So I'll just break it. So this is 37 degrees. So you can break it into 4 and 5. V cos 37 will be 4 and this will be 3. 3, 4, 5 का triangle है ये. So 5 की velocity I have broken it into 3 and 4. So basically the situation is as simple as this, that the mirror, please watch, the mirror is moving with a speed of 8. अब देखना, mirror is moving with a speed of 8 and the car has a speed of 3 and 4. 4 here and 3 here. Clear? ठीक है. Now what will be the velocity of, please watch this, what will be the velocity of the image? Now image कैसे आती है? When you bring the mirror to rest, then it is very easy to analyze the mirror, the image. So this is the object, this is the mirror. You want to know the image? Okay. I think many of you want me to do it in the visual way. So everyone, let's do this question in a visual way. तो अब इसको with respect to the mirror कैसे करते हैं? So you can say that this is the actual situation, ठीक है? Where you are not able to understand what the image velocity will be. So I'm going to say, I'm going to bring the mirror to rest. I'm going to bring the mirror to rest. Okay, bring the mirror to rest. So I will change the situation. I will bring the mirror to rest. Let me bring mirror to rest. To rest. So how do I bring the mirror to rest? I'll give a velocity. How do I bring the mirror to rest? I will give an opposite velocity of 8 and 8 to both of these things. 8 and 8 तो mirror rest पे आ जाएगा, ठीक है? But this situation when the mirror is at rest is with respect to the mirror. So this is a tampered situation. अब ये situation क्या आई? खाली बातों बातों में you will be figuring out everything. So this is the changed situation where the mirror, बच्चों please see this, the mirror has come to rest. अब ये mirror rest पे आ गया क्योंकि 8 and 8 got cancelled और इसका 4 था and 8 था, 3 भी है. तो everyone watch this. Image क्या है? Image क्या है? Image is having a velocity of 3. This will remain unchanged. 4 or 8 है. So 8 minus 4. So it will become 4 over here. This will become 8 minus 4 in this direction. 4 here. Clear? Okay, now this is the object. Please watch this. Now here is the place where we can comment about, because the mirror is at rest, we can comment about the image also. अब बातों ही बातों में we have drawn this. Now this is the image. This was the object and this is the image. Image में क्या है? Obviously if this is 4 here, image will also go away 4. ठीक है? Very visual. 4. Okay, and this is 3. This will also be 3. So learn this algorithm. It's a beautiful thing. बहुत मजा आता है. So 3, 4, 3, 4. This is the velocity of the image. ठीक है? With respect to the mirror. ये पूरी situation with respect to mirror थी. ठीक है? This is with respect to mirror. Now get back to the original situation in which mirror was moving. क्योंकि हमें तो इस situation में चाहिए ना. So again revert back. जो ये changes किए थे, revert back. Now that you have the image, what did I do in the initial problem? I gave 8 and 8 to both. 8 and 8 दोनों को दिए थे. So again, give back that 8. Okay, to all. Give back that 8 to all. 8, 8. इसको भी दे दो 8 क्योंकि आ गया ये भी नया मेहमान. So give 8 to all. That is the original situation. तो अब जब सबको 8 दूंगा, so what do I get? If I give 8 to all, what do I finally get? Please watch. I again get the mirror moving with 8. ठीक है? Now the mirror is moving with 8. Object is moving with 4 and 3 like it was, right? 8 दे दिया मैंने तो this became 4, this became 3. So 4 and 3 like the original situation. Image का क्या हुआ? Image gets an 8. Okay, very good. So this is the image. Now this is with respect to ground. Image का क्या आया? 4 and 8, which is 12. Very satisfying, right? So what is the velocity of the image, bachcho? This is the answer to the velocity of the image. So you can see velocity of image that you're getting is 12 I cap plus 3 j cap. So your correct answer, my dear students, will be option D. This is the correct answer. 12 I cap plus 3 j cap. I hope you really enjoyed doing this problem. So again, it is always great to do this problem like that. You can also apply the fundamental thing over here, right? All the books where you'll find problems like this, they have solved the problem in a very beautiful way theoretically. You can also have a look at this practical way. In this masterclass, you will learn something really new. Chalo guys. Now with this, now let's understand one more concept. Let's have a look at this legendary question. And what is this question? Here, what is happening is there's a bird, okay? There's a bird which is moving downwards, vertically downwards at 1 meters per second. There's a fish trying to swim up at 2 meters per second. Okay, surprisingly, the fish is really fast, 2 meters per second. And the refractive indices of air and water are given as 1 and 2. So my dear students, let's have a look at this amazing question out here. What is the velocity of bird with respect to fish? Okay? What is the velocity of bird with respect to the fish? And let me tell you, generally these kind of questions seem like impossible to do. But trust me students, I will teach you an algorithm here after which these kind of problems will be like a piece of cake. Okay? So before we do this problem, before we even look at this problem, let's have a look at a concept which I'm going to teach you. Okay? So here understand this more like an algorithm. So everyone see, there are different mediums. Okay? So now this I is inside a medium, let's say it's water. And then this is glass, and then probably this is some crystal, and here there is air. So here this is air, right? So I can just say mu is equals to 1 here. It's because it is air, free space or air. And here it is water, so refractive index is given as mu1. Here the refractive index is given as mu2, and here it is given as mu3. So one thing that I know, if understand, if there's an object, let's have a look at this marker. So if this marker is 10 centimeters away from my eye, what will I say? Because my eye and this marker are both in the same medium, मैं बोलूँगा 10 centimeters है, right? But understand this, dynamics will change if I say यहाँ तक water है and then it is air, then the dynamics will change because you already know when you look at a swimming pool, you don't see the real depth, right? But when you put your eyes inside the swimming pool with the sun, with the goggles and everything, you will see the actual depth. But when there are multiple mediums, you don't see the apparent depth or apparent length. So I will teach you an algorithm with which you can write this in one line, and this is super resourceful. Trust me, this will be game changing for all of you. So everyone please have a look. So if you want to find what is the distance that this eye will see, okay, not the actual distance. What is the actual distance between the eye and the object? The actual distance which we as God are seeing. Okay, if we are God and we see this, we'll say the actual distance is w by 2 plus x plus y plus z. So this is the actual distance. ये ऊपर लिख देते हैं. Actual distance, ठीक है? Actual distance is nothing but w by 2 plus x, because this is w by 2 plus x plus y plus z. Okay, but I will not see this because there are multiple media here. Okay, so what the eye will see, I'm going to write that. Okay, what is the actual distance that the eye will see? D that the eye will see. Everyone see this. Now eye is inside this medium, तो इसको ये दिखेगा because it is the eye is also inside mu1, तो ये पूरा का पूरा देख लेगा इसको. So this will be purely seen. So I will write this as w by 2. Okay, width. So this width is w. So this is w by 2. So I will see w by 2. What about this media? Please see. So how do I write this? Then इसको x नहीं दिखेगा. It will see x. Please see. It will see x upon mu2. Please see. X upon the medium in which x is there, mu2. Okay, into the medium in which I is there. I is in mu1. So into mu1. ठीक है? तो इसने इसको तो w by 2 देखा. It's of w by 2 because it is also in that medium. This x is seen as x upon mu2 into the mu where I is there. ठीक है? X upon mu2 into mu1. Then air वाला y कैसे दिखेगा? Y upon y is in which medium? It's in 1. Y upon 1 into into the mu of the medium in which I is there into mu1. ठीक है, into mu1. Okay, z, okay, plus z upon mu3, plus z upon mu3, because z is inside which medium? Mu3. So z upon mu3 into the mu of the medium in which I is there. So into mu1. So this is something which is super duper important, my dear students. Super duper important. Okay? So again, let's do one more simple example to understand if you understood this. So everyone see this. So if I say this is swimming pool, right? So if I say that here there is water, okay, everyone watch this. This is water, and here mu is 4 by 3. Generally the mu of water is 4 by 3. And here there is an object. Okay? This is an object, and the I is here, and the I is here in air. Okay? I is in air. So this mu is 1, mu of air. So what is the distance that the eye will see? The eye will see, not the actual distance. Okay, I'm calling lengths. Let me give you the actual lengths. This is say 2 meters. This is say 4 meters. Okay? This is 2 meters. This is 4 meters. Okay? So let's solve this. So if this is 2 meters, so distance that the eye will see will be 2 meters because it is in the same medium. So 2 to पूरा दिखेगा इसको. Plus what is this? Plus 4 upon 4 is in this medium mu, right? 4 upon 4 by 3 mu of water into 1 because I is in refractive index 1. So what does the eye see? I will see 2 plus 3. So 4 and 4 will get cancelled. So it will actually see 5 meters. It will see the object 5 meters away. So similarly, now if you know this concept, now this problem becomes a piece of cake. Okay, everyone see this. So here, what is the velocity of the bird with respect to fish? So this is an application of the same concept. What is the velocity of the bird with respect to the fish? मतलब who's watching? Fish की आँख देख रही है. So fish is observing. So let's say, बच्चों please see this. Let's say that this length is x and this length is y. ठीक है? This length is x and this length is y. Okay, and the distance between them, okay, is L. The distance between them is L. Okay, now the important thing that you need to understand is, please see, the length, how is the length changing between them with respect to the fish? So you will say L with respect to the fish, the length that the fish sees is x, क्योंकि fish को x तो दिखेगा ही, okay, is x, okay, fish is seeing x distance, plus it is seeing y upon 1, y upon 1 because y is in refractive index 1 into the refractive index of water is given as 2 into 2. Okay? So fish will not see x plus y. Fish will actually see x plus 2y. So this is what the fish will see. Okay? Now everyone please make a note. So everyone knows in mathematics this y is decreasing every second by 1. So what will you write? dy by dt. Rate of change of y is minus 1 because it is reducing. This y is reducing by 1 every second. Similarly, dx by dt की भी value लिख दो. So this is also clearly seen. X is reducing by 2 every second. So dx by dt is minus 2. And obviously they are coming closer to each other. So L will also decrease. We want to find by how much. That is how we will find the answer. So now you differentiate this with respect to time. When you differentiate this with respect to time, you will get dl fish by dt. The length that is reducing with respect to fish will be dx by dt plus 2 times dy by dt. So dx by dt की value डाल दो यहाँ पे -1 plus 2 into -2. So what are you getting? You're getting -5, my dear students, -5. So basically with respect to the fish, the distance is reducing by 5 meters per second. So velocity of the bird with respect to the fish will be 5. So from here you can say that the length is decreasing by 5, or you can clearly say velocity of bird with respect to fish is magnitude में 5 है. And now if you want to write in ij terms also, so you can see it is coming down. Fish will see that it is coming down by 5, down by 5. So 5 into minus j cap or minus 5 j cap. Okay? Vectorially also you can write it. Similarly here you just needed the magnitude 5 meters per second and we are good. Now let's move on. Let's have a look at another question. So let's see if you really understood this concept. Now it is ulta. Now you have to tell me what is the velocity of the fish with respect to the bird. Now the bird is watching. Okay? Now if the bird is watching, my dear students, if the bird is watching, what is the velocity of this machli? Okay? So now everyone, please again, same thing. What was this? This was y and this was x. Okay? At any instant, if this is x and this is y, and this entire length is L. Okay? But what is the bird seeing? तो निकालते हैं. With respect to the bird, what is the length between them? With respect to the bird. So bird will see entire y. इसको पूरा y दिखेगा. Okay? Because bird is inside air और ये air में ही है. Or you can also apply that here also. Y upon 1 into 1 ही आएगा. Y upon the medium in which y is there and the medium in which I is there. I is also in 1. Okay? So it will come out to be y only. So L bird is y plus x upon mu 2. Okay? X upon mu of water, which is 2, into the refractive index in which the bird is there. Okay, great. So L with respect to the bird is y plus x by 2. Okay, here also you write the same things. Y, what is dy by dt? Dy by dt, y is reducing at the rate of 1 meters per second. So dy by dt is -1, it is reducing. Dx by dt is also reducing. Okay? In a case, if the bird, if the fish was going down, you would say x is increasing. Okay, तो plus आ जाता. So dx by dt is also reducing by 2 meters per second, so -2. Dx by dt is reducing. Okay, x is reducing. So you have both the values differentiated and have fun. Okay, so d of L with respect to the bird by dt is equals to dy by dt plus half times dx by dt. So when you put in the values, my dear students, dy by dt क्या है? -1. तो लिख दो इसको -1 plus half times, what is dx by dt? -2. So what are we getting here? -1, so -2. That means this length, my dear students, with respect to the bird is reducing at 2 meters per second. Okay? So what will the bird see? Bird will see, okay, the distance is reducing by 2 every second. Okay, fish is moving with 2 meters per second. Okay? So the velocity of the fish will be 2 meters per second. If you want to write it vectorially, the bird will see that the fish is coming up. So what will be the velocity of the fish? Everyone, what will be the velocity of fish? Velocity of the fish will be 2 I cap. Okay, sorry, 2 j cap. So now let's move on. So my dear students, this is one of the final questions of the day, and this question, trust me, can be done under 10 seconds, or it can also be done in a formal way, in a lengthier way. So again, I would want you to know both of these methods, but for this, we will have to wait for a little while. In this little while, I will tell you exactly what your surprises are. So everyone, please first have a look at what your first surprise is. The first surprise is that at Vedantu Masterclasses, as I said earlier, the fusion of the best of teachers and the best of technology, we have come up with a JEE crash course. So my dear students, let me tell you why Vedantu Masterclasses especially launches the JEE crash course. Because in a JEE crash course, we have seen students who did not take any coaching throughout the year. And especially those students we have seen, especially last year, we had Arjun Murlidhar who had not taken any coaching for 2 years, and he just came for the JEE crash course because he was nervous at the end moments. We nurtured him, and again with the top teachers of the country in the last 60 days, that made all the difference. He cracked JEE Main with a rank of 500, and then after that, when he worked a little more on JEE Advanced, he got a rank of 328. I have seen that kid very closely. He was hardworking, but the one thing that he took was he took JEE crash course very seriously. So my dear students, let me tell you why the JEE crash course at Vedantu Masterclasses works wonders. One, it has the top teachers in the country. Like I'll be teaching physics. We have great teachers for chemistry, mathematics, and all that you need is out here. This crash course will also help you in your preparation and strategy for your 12th board examinations. So how do you avail this life-changing course? Let me tell you. So my dear students, how do you enroll for this life-changing course? Please make a note of this link, vdnt.in/crackjeemain. Okay. So everything is in small. Vedantu is without vowels. It is vdnt.in, not .com. It is vdnt.in/crack main. Okay, so once you go to this URL, you'll be redirected to a secure page at Vedantu. Please make a note. So I'll just give you a quick glimpse of this. So my dear students, please see what I'm doing. I went to my browser. You can go to your PC browser or your mobile browser. Here, just type vdnt.in/crack main. So once you do this and hit enter, so you get redirected to a secure page at Vedantu here, and you can have a look at all the details. And once you pay and enroll for this master course, let me know about it on my email address. My dear students, please make a note of my email address. It is Namo, as in Narendra Modi. It is NAMO @vedantu.com. Please make a note of this. Vedantu.com. I am hyper responsive. So once you take a snapshot of your enrollment in this life-changing course, I will unlock the life-changing second surprise for all of you, which I give to all my students. Being the proud inventor of Turbo Math, I can do that for you. So let me tell you, my dear students, I have created a super useful module, especially for JEE, NEET, AIMS aspirants. And this module will help you crack problems, number-based problems, without even solving them. Now, one thing that you all need to know, I think many of you are not even understanding what I'm talking about. So many students come to me and say, sir, how can you crack a problem without solving it? So my dear students, like I said, this is a surprise which you cannot even begin to imagine how useful it is. For all the students who have taken it, can vouch for it. Everyone, please have a look at a problem. So this is more like a challenge. So I challenge all you students out there to get a calculator, punch in the values, and I can guarantee you that you will take at least 45 to 60 seconds to punch in these values and get the correct answer to this question. Now, okay, now in the middle of all this, just imagine, just close your eyes and imagine if you can solve this question without even solving it. Okay, if you can crack this problem without even solving it, and let me tell you, my dear students, after the second surprise, you will be able to crack this problem in less than 10 seconds. Okay, and in the worst come worst, 15 seconds. So everyone, please have a look at this question. Can you tell me what is the answer? In less than 60 seconds using a calculator. Now imagine cracking the problem in 10 seconds without using a calculator. Have a look at one more such example. There are many such examples which can turn up in our examinations, especially papers like JEE have a lot of questions which involve numbers, right? So we can always arise at a situation like this or a situation like this, or there are many numerous such situations. Everyone can try this also. Under root of 1 plus 40 into 117 into 2911. Can you solve this in seconds? So the answer to all this is the second surprise. Again, being the proud inventor of Turbo Math, I can do that for you. All you have to do, my dear students, I'm again repeating, all you have to do is, once you have taken the first surprise, once you have enrolled for this life-changing JEE crash course, just email me. This is a surprise from my side. So please email me your enrollment link at namo@vedantu.com, and we will definitely unlock the second surprise for you. Let me also tell you, we will also create a group, a messaging group where all the students and all the teachers, I myself will be there, and we will use that for class coordination and also your doubt clearance. Okay. So guys, this is something which comes with JEE crash course, and again, I have not even told you everything about it. So there is quite a lot which is bundled with it. So again, don't miss this one out. Everyone also have a look at the challenger now. So everyone, what was the challenger? What is the velocity of the laser point? So everyone visualize this. We've played with laser. So when we take a laser light like this, तो जब हम laser light को ऐसे करते हैं तो वो जो red color का point होता है, so the red color का point actually runs, right? You know, when you rotate the laser like this, the point really runs. Okay, after a while it has reached a long distance when you rotate it like this. So here also a very similar thing is given, that when you're rotating the laser at 3 radians per second, so this is your omega at which you are rotating it, or this is the rate at which you are changing this theta, right? Theta is omega, right? D theta by dt, rate at which this omega increases is your theta. Okay? D theta by dt is omega. So this is 3 radians per second. First, I'll tell you the formal mathematical way of solving this problem. So what do you have to find out? You have to find out at what speed does this move. We will also look at the 10-second way after this. Everyone see this. So this is the point, and you know As a matter of fact, you know that this point will move on the floor. ठीक है? Like this. ऐसे जा रहा होगा. You want to find what this velocity of this point is. So one good way is this is given as 3. 3 is constant. Okay, this 3 meters is constant. What is varying, my dear students? What is varying? If I call this distance as x, ठीक है? There are two things which are varying, and that is this x is increasing and this theta is also increasing. Everyone knows this. This theta is varying, this x is varying, 3 is a constant. So what is the mathematical relationship that we can write at this point in time? We can write tan theta is x by 3. We can write this from this triangle. Tan theta is x by 3. Okay, good. So once you write tan theta is x by 3, after that, if you differentiate this, everyone see this. If I differentiate it, I'll just write it again. 3 tan theta is equals to x. Now from this I know that x is increasing. X is the length which is increasing at the rate of v meters per second, which we have to find out. So as a matter of fact, we have also written one more important thing, that dx by dt, rate at which x is increasing, is nothing but the velocity of that point. Dx by dt is plus v meters per second. Okay, now let's differentiate this equation with respect to time. So when we differentiate it, okay, we do d of dt of tan theta. Please see this. D of dt of tan theta is equals to d by dt of x, dx by dt. ये तो v हो जाएगा. But everyone see, इसको sec square theta immediately मत लिख देना, because you cannot differentiate tan of theta with respect to t. So you'll have to apply the chain rule. So how do you apply the chain rule? Please watch this step. This is the most important step. You will differentiate tan theta first with respect to theta. First with respect to theta into d theta upon dt. So you've created this chain. Chain rule ये होता है ना? You've created this chain over here of d theta, right? So this is what you do. dt से नहीं हो रहा था, so you differentiated with theta into d theta by dt is equals to dx by dt. And यहाँ से पता चल रहा है ना, rate at which theta is changing is omega. Omega is nothing but d theta by dt. So d theta by dt is also given to you as 3. So now everyone can work it out to find the answer. तो ये इसको v लिख दोगे तुम. Everyone see this. This is nothing but omega. This is nothing but v. ठीक है, velocity which you have to find out. And what is this? Let's work it out. So this will be 3 sec square theta, 3 sec square theta, differentiation of tan theta into omega is equals to v. Omega is given as 3. So this will be 9 sec square theta is equals to v. At this instant, what is the value of theta? Sec theta क्या है? So everyone, if you notice that this is what? What is this? This is 37 degrees. Everyone see this. This is 37 degrees. So at this point, theta will be how much? 53 degrees. ठीक है? 53 degrees होगा theta. और क्या होगा? 53 degrees होगा, because this is 37. It is given at this instant. So what is cos of 53 degrees? Cosine of 53 degrees, I think all of you know, is equals to sine 37. Okay, complementary angles. So this is 3 by 5. 3 by 5. Okay, so if this is 3 by 5, what is sec 53? Sec 53 degrees is, because theta is 53 degrees, 5 by 3. So so you will use this value of sec theta over here. Okay, you will use this value of sec theta over here. So what do you get? Velocity is equals to 9 into sec square theta, which will be 25 upon 9. Okay, square इसका 25 by 9 है. So what do you get? You get 25 meters per second. Okay, so we did spend some good amount of time and a lot of practice of we used a lot of things, right? So we used calculus, we used mathematics to a great level. So we needed an in-depth understanding of doing this problem. Can we do this problem using a simple trick of circular motion? Yes. In that case, we can solve this question in seconds. So my dear students, let's have a look at the same challenger problem in a different light. So this is the way to solve this question like a pro. तो अब अगर ये ओमेगा है 3 रेडियंस पर सेकेंड, दिस इज ओमेगा, राइट? इफ दिस इज ओमेगा, तो ये डिस्टेंस क्या है जल्दी से बताओ. दिस इफ दिस इज 3, दिस इज 37 डिग्रीज. इफ दिस इज 3, दिस विल बी 4. 37 डिग्रीज वाला ट्राइंगल 3 4 5, राइट? So this will be 4. You can figure it out using trigonometry also, because tan 37 is 3 by 4. So this will be 4 and this will be 5, right? So 3 4 5 वाला triangle है. So you've not even started with the problem. You're just figuring it out. अब देखो, please have a look. Now everyone knows that this point, please see, this point has a resultant velocity here, BAP velocity, क्योंकि पता है ये, because of visualization you know it moves here. ठीक है, you know that it moves here, you want to find this V. You cannot find V, but you can find one component of V. I'll tell you how you find it using circular motion. What is this perpendicular component, bachcho? What is this? Everyone tell me what is this component? This will be nothing but 5 omega. Okay, because this radius is 5 and this is omega. So 5 omega, r omega, say tangential component of velocity, you can easily find using circular motion ka funda. So r into omega, right? This is omega, this is 5 omega. So 5 omega will be 15 meters per second. But understand, this is 15 meters per second, right? Ye perpendicular hai yahan pe. So if this is 37, this is 53 degrees. So everyone knows, should I do V cos 53 is equals to 15 or 15 cos 53? Like I said, this is the BAP velocity. We know that that point is moving here. So this is the resultant velocity. So all you do is V cos 53 degrees is equals to this component 15. And my dear students, that is how you do this problem like a pro. So cos 53 will be 3 by 5, which will be equal to 15, and 3 5s are 15, so velocity is 25. So my dear students, that is the way of doing this problem in seconds. Apart from that, don't forget, this is the link to enroll for this life-changing crash course. Again, this is the JEE crash course by Vedantu Masterclasses, the classic fusion of the best of teachers and the best of technology. It's VDNT Vedantu without vowels.in/crack JEE main. Once you enroll for this life-changing course, take a snapshot, take a picture, and send me at namo@vedantu.com. Namo as in Narendra Modi. So once you have done that, send me the snapshot. I'm hyper responsive. I will reply you back with the second surprise. So that was great, my dear students. It was lovely interacting with all of you. So again, I'll be coming back very soon. In the comments, let me know which is the next chapter you would like me to come up with in the Vedantu master classes that we stream. So with that, my dear students, over and out. Do not forget to like, share and subscribe. Thank you so much and love you all.